want to spend a little bit of time talking about our balancing the equation or understanding what the equal sign means, TEK for first graders. So that's 1.5e, and it just says students need to understand that the equal sign represents a relationship where the expressions on each side of the equal sign represent the same value. So it just means that whatever's happening on this side of the equal sign is equal to whatever's happening on this side of the equal sign. It doesn't mean give me an answer. So what I mean by that is we've got to have variety for kids. So if all my kids ever see is problems like 6 plus 3 equals blank, 4 minus 1 equals blank, 6 plus 8 equals blank. If this is the only kind of problem they ever see, they develop this idea that the equal sign means tell me what the answer is. So I have to vary that by doing things like blank equals 6 plus 3, moving the equal sign around. Could be 6 plus blank equals 4 plus 7. So that kids see that things can happen on both sides of the equal sign. And they see here 6 plus blank equals 4. That doesn't make sense to a kid who thinks that the equal sign means give me an answer, because they don't understand yet that this side has to equal this side, not just these two things added together equals this blank. So switching that equal sign, let's say we did 6 plus 3 equals blank plus 2. If you have kids that put a 9 here, then you know they don't understand that the equal sign means that both sides are equal. They think it means tell me the answer to this. So if I write 9 here, that's not true, because 9 plus 2 is 11, not 6 plus 3 is 9. So this side has to equal 9. What plus 2 would also equal 9? And that sounds tough for a kiddo, so we have to be careful how we model that. One of the important parts of that is how we write equations. So what we don't want to do if we were trying to help kids understand this is we don't want to write, okay, well 6 plus 3 does equal 9, plus 2 more equals 11. This isn't a true string, because 6 plus 3 does not equal 11. Even though this part is true, this is not a true statement. So we tend to do that as adults because we're adding in chunks. When kids see this, then we've confused them about this understanding that both sides of the equal sign are true. So one way that I modeled at the CNP to do this, and I'm hoping it's going to do fine on the camera, we're going to find out, is with a balanced scale. So let's say I had the equation. Let's see if I left myself enough room to write. 5 plus 2 equals blank plus 3. Oh, you sort of could see part of it, and then you couldn't see it anymore. How's that? Now I think you can see it, and I've got my scale off balance. So when we do this with a balanced scale, we have to use objects that have the same weight so that it makes sense to kids. So if I have 5 over here, and then I join 2 more with it, I know that I've got 7 on this side, and I'm not sure if the scale is going to work great. And I know I'm supposed to put something with 3 to make it balance. Well, I can see right now, you may not be able to see, but I can see that my scale is not balanced. And if kids were sitting in front of it, then they could see that the mark here where it lines up is over here, so it's not balanced. But if I put 4 more with it, now, as soon as it quits bouncing around, now my scale is balanced because both sides equal the same. Now, I would want to have kids test that out and say, okay, well, what if I put 1 more with it? Is it balanced yet? Not yet. What if I put 2 more with it? Is it balanced now? No. What about if I put 3 more with it? It's going to take me 4 more to get it to balance. So then I could talk about, well, it took 4 to balance the scale. Why is that true? What is 5 plus 2? Oh, 5 plus 2 is 7. Well, what is 4 plus 3? 4 plus 3 is also 7. So my scale is balanced because I have 7 objects on this side and 7 objects on this side. My equations are balanced because this side equals 7 and this side equals 7. If I have a kiddo who doesn't understand this and keeps putting 7 right here, then I could put 10 objects on this side and show them my scale's not balanced anymore. This can't be 7 because 7 plus 3 more makes my scale no longer balanced, and my equal sign's not balanced because this side of my equal sign would equal 10. So I hope that helps you understand that TEK and how we talked about using a balanced scale with kiddos to build this understanding at our CNP.